All right, back with some more Algebra 2 videos or exponential videos. My students should now be comfortable with this APR form that they've been using of an exponential equation where it's not been compounded. And today we're going to show how you can change that form if there is a compounded interest. Everything's the same, you just added a new variable, n gets added in. All right, but the same thing where A is the total amount, the ending amount, P is the principal or the starting amount, it's how much you initially invested or how much population you started with, starting amount. 1 is always there. All right, always start with, it's basically saying I start with 100% and then I grow from 100% or I decay from 100%. And then you got your R, which is your rate as a decimal, all right? If your rate is 3%, you don't put 3 there, you put 0.03. If your rate is 50%, you don't put 50 there, you put 0.5. So that is the rate as a decimal. And then T is time, all right? Same thing, total amount, principal, your starting amount, you got your 1, you got your rate as a decimal, and you got your time, except for we're going to add in n, where n is the number of times it's compounded. Okay, and some things that you will need to remember is if it says compounded, and then if it says any of these words, I'm going to show you what n would equal for them. So if it says compounded annually, n equals 1. If it says semi-annually, well, hopefully remember semicircle, semi is cut in half. All right, so n would equal 2, half of a year. And then you can get quarterly. So there's 4 quarters in a year. And then maybe monthly would be 1. And that would be n equals 12. Daily, n equals 365. See, all these are mostly based off of annual. It's based off of a year, so how many times is it compounded within a year? If it's compounded annually, then it's compounded once within 1 year. If it's compounded semi-annually, it's compounded twice. So in June, and then again in December. So the 6th month and the 12th month. This is every quarter, so every 3 months. This is every single month. This is every single day. Then you can do hourly, by second. And this can change depending on if you're going by years. Maybe it's compounding within a day. All the problems my students are going to be doing, though, is based off of how many times is it compounded within a year. All right, and that's usually because you're taking out a loan, savings account, buying a car, financing. Usually not a lot of those are compounded, but if they are, they're going to be compounded within a fiscal year, so a financial year. All right, so we're going to do compounding within a year. So now might be the time that you skip ahead because I have to write out a story problem. And for the sake of making this, connecting this to something you guys already understand, usually some juniors and seniors have jobs by this time, by the time they're juniors and seniors, and might already have a savings account, or at least maybe your parents opened a savings account for you when you were a kid, teenager. So we're gonna start with savings accounts at a bank. So this is Bob. Bob opened up a savings account at his local bank. He opened with $1,000, and it earns, let's do 1.8% interest annually. Period. Get to the question, how much interest did he earn after 8 years with no, this is very key, it's got to be with no further deposits. With no further Now, when you guys open a savings account, you're probably going to put like every month a little bit of your paycheck or every week, whatever, into your savings account. For the sake of this problem, for the sake of the math, that math gets a little bit more difficult, and you guys can actually find online calculators that'll do it for you, where you can type in, I'm going to open the account with $1,000, I'm going to put in, and it earns this interest, and I'm going to put away $50 every single month for 10 years, and it'll calculate it for you online. But for the sake of learning how to do this math and the equation we're using, you need to think about it as though you're just going to put in $1,000 and just let it sit and earn interest, right? It's earning money as you sleep. It's earning money as you go to work. You put $1,000 there and you do not touch it, and it will earn money. All right, so now let's highlight, or let's just write over the key things, grab a different color out of the story problem. So, opened with $1,000, so that would be P equals 1,000. We got 1.8% interest, so that would be R will equal 0.018. Remember, R is the decimal of the percent, so you got to move the decimal once, twice. All right. What in the... Why do I have too many zeros? I'm tripping. Oh, yeah, I know why. Because okay, there we go. That's why I'm tripping. Okay, so, right, you get 0.018. That's all I got. Except for I put a little extra zero in here. You can put another zero on this side. So 0.018 interest annually. All right. In that, I did not hear the word compound. The word compound is not in there. So I'm not going to use the compound formula. I'm going to use the original formula where there is no n, because this is the word compound is not in this story problem. It is not in there. All right. And then I know what time is, because that is 8 years. So t equals 8. So I can erase all of this stuff. All right. Black marker again. So we have A, because we're trying to find the total amount. We want to find, well, actually, I need to write this over here. The question, if you go back, I wanted to find the amount of interest. So we want to know amount of interest earned. All right. So A, our total amount of money, how much money will be in that bank after 8 years. We start with 1,000. Then we got 1 plus, because it's the savings account, we're earning money, so we're adding 0.018 over 8 years. All right, and if I grab a calculator, And if I type that all in, you got 1,000, parenthesis 1 plus 0.018, parenthesis up caret 8. We get A equals 40604. And the decimal keeps going. So we're talking about money, which means you need to round to cents. Okay, so we need to round to cents, so we need to round up, because 6 rounds up. So after 8 years, Bob, without adding any money, after 8 years, his $1,000 will turn into $1,153.41. Now, which is awesome, right? He just put this money in an account and it grew after 8 years. What is 100 divided by 15? It grew almost 7%. All right, awesome. No, that's more than 7%. 1,000 divided by $150. That's because I'm doing the wrong thing. It's 150 divided by $1,000. 15%, duh. Why am I doing that math? It grew 15% by doing nothing. It earned money. It's earning money while you're sleeping. The question is, though, how much money will be in the account after 8 years? Or is the question how much interest did it earn after 8 years? So it didn't earn $1,153.41. There was already $1,000 in there. So all you do is you come over and you subtract off 1,000, and you should get 153.41 dollars. So that's how much money Bob earned by doing no work. The money did the work for him. That's why savings accounts are awesome, and you need to start one as soon as possible and put money into it. Imagine if that was $10,000. Then that $10,000 would have earned $1,000, $1,500. Or imagine if it was $100,000. Then that would have earned $15,000. All right. Savings accounts are awesome. So, don't want to make this video too long, so I'm going to show you now a compounded one, right? This one was not compounded. The story problem did not have the word compounded in it. So that's what we're going to look for in this story problem. Obviously, I'm going to put it in there for the sake of having an example of it. So let's say Sarah opened a bank account she's going to open it with a little bit more money. Her account, oh, that's ugly. I got to fix that. Her account will earn, let's do 2.2% interest compounded semi-annually, period. How much? I'm gonna do the same time frame so we can see how ridiculous or how much better this situation would be. I know I also raised the interest. Actually, let's make the interest the same as the other problem. Let's make the interest also 1.8%. So how much interest will she earn after, gotta look at the calculator, how many years did I do? Was it 8? It was 8 years after all right. So go through and highlight all the important information that you need. Starting with $10,000, we got 1% interest. It is compounded semi-annually, and it's gonna be after 8 years. So P equals 10,000, R equals, again, 0.018. N equals 2 semi-annually, half a year. There's 2 half a years in a year, all right? And then T equals A. So I know my students are getting this on a computer, so they can't exactly underline and highlight the information, but maybe write down on a piece of scratch paper the key pieces of information to then turn it into an exponential function equation. Now we're going to solve. So again, I'm going to write up here what it wants. We want how much interest earned. All right, so A equals 10,000 times 1 plus, now we're doing compounded, so it's compounded, so we have a fraction bar with our R on top, so 0.018, and N on the bottom. And then up here, you're gonna have N times T, right? So I'll write it up here. A equals P times 1 plus or minus R over N times T. So now we have 2 times 8. 2 times 8. All right, so I'm gonna type all that in. And for my students, I strongly suggest you use Desmos, because if you use your phone calculator, you might mess up PEMDAS in your order of operations. It might not come out right. So we have 10,000, 1 plus 0.018 divided by 2 up caret. And then I'm just gonna type in 16 because that's what 2 times 8 is. All right. So we get A equals all right, now we got to round to money. Does that 4 round to 0? No, it does not. All right, so we have 11,541 and 40 cents. But again, we don't want how much money is there after 8 years. We want how much interest was earned. So we're going to subtract off what we started with. And you should get $1,541.40. That's how much money, that's a lot of money. I don't know about you, but that's a lot of money that I didn't have to do anything for. Sarah, she accumulated $10,000, you know, she saved, she worked her butt off, she saved $10,000. But then that $10,000 made her that much money without doing anything. She didn't have to do work for that money. Her money earned it for her. Now, you're probably not going to get a savings account that is that amazing, all right? Usually savings accounts aren't going to be compounded interest. I don't know, maybe look out, maybe something will change in your guys' lifetime. But that's awesome to me. That's how much interest would be earned. Compound, all right? You just add an N. That's the only difference. You just add an N. Hopefully that helps my students. I feel like this video is really long and I talk too much. I miss teaching and I miss being in my classroom. Yeah, hope that helped.